Hi, our next speaker is going to be talking about the UHPC on county bridges, and Jimmy D. Camp with Maricopa County.
Hello, my name is Jimmy Camp. I'm with Maricopa County DOT. Maricopa County is basically a greater Phoenix. So I'm out of Arizona. I've been the bridge engineering manager there for almost 10 years. Prior to that, I worked with New Mexico DOT. I held the position of state bridge engineer for over a decade here. So anyway, it's good to kind of come back home, visit, and anyway, I'm going to share some experiences I've had with UHPC. So to give us a little background on our inventory, and we're a big county, but still we are a county. We have 71 span bridges, and many of them are over canals or rivers or washes. The average age of our bridges were built in 1986, so we have a fairly new inventory of bridges. We have several bridges that are pretty good size. We have 8 of them that are over 600 feet in length. We have several of them that are approaching. Several of those are around 1,500 feet in length. They're pretty major waterway crossings. And then we have quite a few smaller, shorter bridges, and a lot of our bridges are over irrigation canals, and they kind of create their own. They have unique problems. If you've ever worked with railroads, you know it's how difficult it is to work with railroads. Well, irrigation companies are also somewhat difficult to work with. They usually have prior rights, and whenever you work on a bridge in their jurisdiction, you pretty much do what they tell you to do. So I don't know, it's been about 6-7 years ago. Actually when I was with New Mexico, we started UHPC with New Mexico State University when I was with New Mexico, and then years later I was attending a conference in Tucson, and we had a professor from ASU, and he was giving a presentation on UHPC, and he said, well, I saw that New Mexico was doing something with it, and we didn't want to be outdone by New Mexico, so we started doing something with UHPC in Arizona. So he had worked with ADOT on a research project, and they had developed a mix at that point. And then as a county, we were interested in using it in an application. So we actually got started and did a project. We basically, UHPC is a real. It's more than anything else. It's somewhat like a cement rock is what you kind of end up with. Your main material is cement, and then you follow that by a fair amount of sand, but your sand is less weight, less volume than the cement. And then you add some silica fume and some fly ash, and then you actually add a little bit of water, very, very little water. You want to keep the water cement ratio around 0.2 or so. I think we were using 0.18. And then you use some super plasticizer, and then we add these fibers, and I don't know if you can see the fibers on the screen there to your left, but they look like they're gold, and they are gold. No, they're when they make these steel fibers, when they're in the manufacturing process, they somehow use brass as a lubricant, and so when you get the product, they're actually steel fibers with just a real fine brass coating on them. Anyway, we kind of showed, we did some trial batches, and we did a little mock-up for a bridge project we had done. if you've ever worked with UHPC, you know, it's supposed to be ultra-high performance concrete. If you've ever worked at it, one time or another, you're going to call it ultra-high problematic concoction, because there's going to be some problems. There really are. And you really got to get the owner on board. You got to get the contractor. You got to get your materials group. You got to get everybody on board. And if everybody isn't on board, you're gonna have a problem. You really are. The mixes can really change, but what you do, you basically mix a little bit of the water and some of the sand, and then you add your dry materials and your wet materials, and incrementally till you get to a point, and it mixes pretty good for a while. The first 15 minutes of mixing, everything's happy and everything's real fluffy, and I don't know, it works fine, and then all of a sudden that stuff starts to turn, and it turns to a taffy state. And that taffy state, it's just like you think of taffy if you were mixing it in a hand by hand. It turns to taffy, and those old mixers, boy, it's just all they can do to mix through that taffy stage of the material. And once it finally gets out of that taffy stage, then it just kind of flashes into a very flowable mix. And then it's easy to mix again. But I know when we were mixing some of our trial batches, we had times where our mixers they froze. They could not mix through that taffy stage. Our contractor actually went from, I believe, from a 13 or 14 horsepower engine to 21, 22 horsepower engine, so they could always make sure they could mix through that taffy stage of the material. But over to the right, that's a little mock-up pour we did on one of our first bridges. Well, the only bridge we've done, actually. So basically what we had two solid planks. I think these planks, the span length was about 36 foot in length or so. And then the problem we've always had with these side-by-side pre-stressed slabs is we always use that little key joint that you just put in the little grout key, and that grout key will hold up anywhere from about 5 to 15 years, and then it's always going to fail, and then you start to get water through the joints, and and then eventually the slabs start acting independently, and they don't act together as the structural engineer intended. But anyway, you can see over on the left, we just put in bars that lapped. They basically didn't even touch, but they lapped over about 5 inches. We had a 6-inch gap and a 5-inch, and 5 inches in UHPC is plenty of development length. UHPC is a very unique material. It's a very good material. But it's like I say, if you go to use it, don't expect that it's just that easy of putting out a specification and the contractor's going to do it and everything's going to turn out perfect. You're going to have to spend a lot of time with it, and you're going to have other people on your team that's going to have to help you and make sure you get it right. This was our bridge that we finished. We took the easy way out, I guess. We basically poured the joint with UHPC. In this case, I believe we used about 8 to 9 cubic yards of UHPC to fill 13 joints, and the joints were like, I don't know, roughly 38 feet in length or so. And then when we were done, I know a lot of people will pour that UHPC a little bit higher and then grind it off and make it equal. I guess we took the easy way out. We covered it all with asphalt when we were done. So we were trying to make it easy for the contractor and for us and for everybody. We didn't want anybody to feel like they had to take on a lot of extra risk on something that would be problematic. So anyway, we're very happy with our structure. Like I say, we had those UHPC reinforced keyways, and I think, boy, I'm confident they will outlast the pre-stressed members. And the loading as you're out on the bridge now, where before we had 4-foot wide slabs, and you could see the different deflection with the existing girders, and I really don't think we'll see any leakage between the slabs anymore, so we're very, very happy. I don't know if you can see these photos very well or not, but these were photos of before this was the old bridge, and you can kind of see longitudinal gaps right over those grouted keyways. And our maintenance folks were out there about every 9 months patching the asphalt on this bridge. And this was near a dairy, and we probably had, I don't know, 100 to 200 trucks a day going over this bridge. And the truckers learned real quick. They would always slow down when they came to the bridge, and I don't know, it was problematic. Each of these slabs were acting independently. There was a lot of leakage, and then when this bridge was built, it was built such that the canal, it raised the canal. So this thing actually, the bottom 6 inches of the bridge actually was in water, in 6 inches of water for various times during its life. So the bottom of the pre-stress was in the wet, dry zone, the worst place you could have had it. So when we built the new bridge, we actually raised the bridge up another, I don't know, about a foot or so we won't have the bridge in water anymore. And like you can just see some of the problems, but we used to have our maintenance crews out there patching it all the time. You can see the canal just barely in the upper left. But anyway, that was our first project, and we thought it was a success. We're very pleased, so we're planning another project now with UHPC. So we have a lot of these side-by-side voided slabs that have the grouted shear key, and the slabs overall, the pre-stressed voided slabs are in good condition. The whole issue is we're not getting a good load transfer from laterally from when one side deflects, it brings the adjacent slab down with it. And so we're kind of like, well, what can we do to get this to work? And we think we can use UHPC to make these existing slabs act together by doing a retrofit. So we have this existing bridge over a canal. It's 52 foot wide, so 52 divided by 4, it's got like 13 panels, I think, or well, maybe that's not right, whatever the number is. But anyway, we've got that regular grouted keyway, and that's a one that always fails. Anybody that's been around these bridges, you just know that grouted keyway doesn't last very long. And so the original load path of the original design, we're basically saying we want the truck on one of the pre-stressed slabs, and we would like the load to be taken by some adjacent slabs as well. So, and then if you look at kind of the load path of that, you'd basically, you got to get that shear key to work. If that shear key doesn't work, well, then you got this happening. You got basically all the load taken by a single panel, and then, like I say, even if your bridge is strong enough to handle this, the issue is then you're getting water in that shear key, and you're getting deterioration, you're getting problems. So, like I say, water is some of the worst enemies we have to civil structures, and so anyway, we were looking at ways that we could retrofit. So we'll take this bridge here that basically has got these shear keys that don't work, grouted shear keys, and then we're trying to come up with some sort of load transfer mechanism, and we've kind of come up with a way with UHPC where you can, UHPC will develop a bar in just, like a number 6 bar in 5 inches, or a number 8 or 10 bar. You only need 7 or 8 inches of development length. So we're thinking we can use UHPC to come up with some ways to get this load transfer to happen. And so if you kind of, I'm looking at putting in together a steel assembly, put these steel assembly. It'd be like staples along the joint. You'd put these staples in every 6 feet or so along the adjacent girders, adjacent slabs. And as you kind of look at the loads, you're like, well, how would the loads get transferred? And I don't know. We've kind of come up with, you look at. I guess I kind of said, well, if I just take a regular axle load from a HS20 truck, and if I'm able to transfer that with one of these staples, that should be a pretty good number to use. So basically, I was taking a 16 kip load with a 30% impact, so I'm taking 20.8 kips, and I'm trying to get that. Half of that to transfer across through one of these staples. So if I get that to work, I've got to get the mechanism to transfer the loads. And if I put some numbers to this, and like I say, I'm going to assume that I don't have any compressive reaction on the left from the concrete, and I think I can get the pull out on the right side there, the 10.4 up and 10.4 down. And then on the other side, if I draw a free body diagram of this whole thing, I can basically, I'm pretty sure I can get a pull out of the 30.2 kips. And then, but anyway, I'm pretty confident that I can work with UHPC and do a retrofit on these structures. Like I say, you can run these quite a few different ways. The other thing I can do, I can always put more staples in. I can instead of putting them at 6 feet apart, I can put them at 3 feet apart or that if I need to. But anyway, the bridge we're looking at now, we're looking at putting these structural assemblies or staples in at about every 6 feet. We're basically coring some holes in each of the adjacent voided slabs, and we're cutting out the existing shear key. Then we're going to basically pour the core holes and the part we cut out in the middle where the old grout key was, and we'll fill that in all with UHPC at one time. And then as a second project, our second phase of the project, we'll put an overlay. We'll either put a UHPC overlay or a polyester overlay, depending on our research and that. So anyway, that's kind of what we have coming up. But anyway, we're looking forward to working with UHPC here in the future. I see that it has a place for our industry and for preventative maintenance type projects. And anyway, we're looking forward to doing this Centennial Road Bridge with trying to get these slabs to work together. We're hoping to do that later this year.
So is that UHPC mix not proprietary? Because that's one of the issues that I know some states are facing is there's that proprietary UHPC mix and speccing that into jobs. So states are looking to try and develop that independently.
Yeah, that's correct. This is a non-proprietary UHPC mix that, like I say, it was kind of New Mexico State University had somewhat worked on it, and then ASU had started and done it with Arizona materials. So yeah, it's a non-proprietary mix.
Thank you, Jimmy.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.